Good morning, my mathematicians. Today we are going to continue with solving rational equations. We are actually going to build on what you guys did on Monday, where you had monomials in your denominator. Today we're going to look a little further and look at actually having polynomials in your denominator. So here is your PDF file for today for the work. If you notice our do now, it's actually the last question that you guys had on your classwork for Monday. So the 17 divided by x minus 11 divided by x plus 3 equals 5x plus 8 divided by x plus 3. That was your last question on Monday. I want to start by reviewing that because a lot of you guys got caught up in this one. So I have it over here on our whiteboard, smartboard, I guess. So we want to solve this, and we know that since I'm trying to add or subtract these rational expressions here, I need to start by finding, like, okay, what is my, oh gosh, thank God this is not a real whiteboard. We need to start by finding, like, what is my least common denominator between those values there. So I'm looking at each of my denominators here. I'm looking at this one, and this one, all of them. And I notice, like, I see an x, and then I see an x plus 3. Spoiler, do not copy this down. So a lot of you guys wrote that the least common denominator was x plus 3. And a reminder, whenever I find out what that LCD is, you take that value and you multiply it by that rational expression. So if I took x plus 3 and I multiplied it by, like, this rational expression there, in your denominator here, you're not going to get an x plus 3. Like, some of you guys were writing 3 to multiply this by 3. If that's the case, then you're left with 3x. And that's not the same thing as x plus 3. And then even if you multiply this by, like, x plus 3, then you're going to have x times x plus 3. And that's not the same thing. So remember, when you have rational expressions, the only way you can change the denominator is by multiplication. And I basically, since I have different polynomials here in my denominator, I need to factor them. But you're looking at each of these, and I know you're thinking, like, these are already factored, miss, there's nothing I can do. And you're exactly right, they are already factored. So what you need to do is make them equal to each other. You need to combine them together. So, like, this one has x, this one has x plus 3, this one has x plus 3. That means my least common denominator is really x plus 3 times x, this entire thing. Normally you see it given to you like x squared plus 3x, and then you have to factor it and you get this. Well, here I basically gave it to you already factored. So knowing that, I'm going to erase this for less confusion. Knowing that this rational expression here already has an x, I'm looking at my least common denominator and I'm saying, like, okay, what's missing from there? So since this has an x, what's missing is this x plus 3. So that's what I need to multiply this by. Your x's are going to cancel out completely. So I'm going to have 17 times x plus 3. Then I have, like, this subtraction, and I'm looking at this rational expression, and here I see, like, okay, it has x plus 3. Well, from my least common denominator, what's missing from it? Oh, it's missing that x. So that's what I need to multiply this by. Because again, when I go to multiply it by my least common denominator, those values there are going to cancel out. So I'm going to be left with 11 times x, which is really just 11x, equals. And you also need to be multiplying everything. Otherwise, you don't have an equal equation. So this needs to be multiplied by your least common denominator as well. That x plus 3. But notice, this is already in common. So I'm really just multiplying 5x plus 8 times x. And it completely destroyed your fraction there. Now my next step is going to be, like, okay, let's actually distribute out these values here. So I'm going to have 17x, then I'm going to do 17 times 3, which is going to give me a 51. And then I'm going to have that subtraction sign with this 11x. We don't even need to write that in parentheses there. And then I'm going to distribute on this side, this x to both terms there. So I'm really going to have a 5x squared plus 8x. Okay? And now at this point, we should be thinking like, okay, I need to bring all of my like terms together here. So like I see this 17 and this 11, negative 11x, they are like terms. And since they're on the same side, that allows me to just bring them together. And I'm going to rewrite that as a 6x. Now my next step is going to be like, I want to set this equation equal to 0. So in order to do that here, I need to start bringing my terms over to each other. And since I'm bringing one value like of my equation over to the other, I must do my inverse operation. So I'm going to subtract this 6x and bring that over here. And I'm going to have 5x squared. When I'm combining this 8x and 6x, that should leave you with a positive 2x. And I'm also going to subtract this 51. So I'm going to have a negative 51 here. And that's equal to 0. But no, you're not done, because remember, we're actually solving this equation. And I want to know, like, what is x equal to here? So yes, this is good old AC grouping. So I'm going to take my a value, and I'm going to multiply that with my c. So I'm going to do 5 times negative 51. And I'm going to have x squared plus 2x minus 255. And now this looks like good old ABC method. Now we know, like I already know that you're thinking in your head, negative 255, that's a massive number to think of factors for. So remember your shortcut. Open up your graphing calculator app on your phone, or take out your calculator, go into your y equals, and type in whatever your c value is, which in this case it is 255. So I'm going to type that in, and I'm going to divide that by x. And I'm going to hit second graph, and I don't want the answer right there. So I'm going to look anywhere I see like whole numbers like 5 and 51, that means that it's a factor there. So I'm going to scroll through my table until I see a pair that adds up to a positive 2. Oh, 15 and 17. That's what I need here. I'm going to go over here for some room. So instead of writing x squared, I'm now going to undo what I did. I'm going to bring that 5x squared back to the front. And I'm going to expand out like, okay, I had a plus 15x. Sorry, it needs to be a minus 15x because I need to add up to a positive 2. Plus 17x minus 51. So I went back to my original. And now I know when I have 4 terms, I got to group those into pairs. Always grouping my first 2, then I'm grouping my last 2. And I'm looking for a GCF between these terms. So I'm going to have 5x, x minus 3, plus. Now I'm looking at 17 and 51. Yes, your GCF there should be a positive 17, which will leave you with an x minus 3. Notice these two are identical. That's perfect. You're pulling out a GCF here of x minus 3. So that allows you to group 5x plus 17, x minus 3, and solve each of those. Set each of those factors equal to 0. When you finish that, you should get x equals 3, and you should get x equals negative 17 divided by 5. And that's your final answer for this question. So yes, it was extremely challenging. I know some of you guys were struggling with that, and that's okay because that's what today's lesson is on. We're going to start looking at denominators where they are polynomials. They're not just monomials. They're not just numbers in your denominator. So take a minute, rewind if you need to, copy down what you need to, and we're going to look at the next example here. So notice I have polynomials in my example. So because fractional equations often have denominators containing variables, that's what we've been seeing, it's important to see if we have any extra solutions. Flashback to when we were solving square root equations. We had to look for extraneous solutions. We want to do the same exact thing here. I want to look for extraneous roots. So we're going to do the same exact process. I'm going to start by solving that rational function. My only extra step here is going to be like, okay, let's check my solution. Is that actually my solution, or is it an extra value? And if you're getting confused, like what would make my solution an extra value? Remember, we can't have 0 in my denominator. So if any of the solutions I find give me 0 in the denominator, that means that it is extraneous. So I'm copying this down onto my smartboard, or my whiteboard, I keep saying that. And why I copy that down, you should be thinking, okay, what is my least common denominator? So I'm looking at this expression here. I want to know what is my least common denominator. Well, in order to figure out my least common denominator when I have polynomials, I need to factor them. So yes, x plus 5 and x plus 3, that is factored. But now it comes down to like, I need to factor out this guy here. So let's look at my x squared plus 8x plus 15. And what factoring method should I be using here? Yes, Lyra, you absolutely should be using ABC method. So I want to look at my factors of 15 and figure out, okay, which of those values are going to add up to a positive 8? Yes, Sam, you should have x plus 5 times x plus 3. So really, I could rewrite this whole entire rational expression as x plus 5 times x plus 3 if I wanted to. But we don't need to do that. And now that I'm looking at my least common denominators here, I know like this is x plus 5, this is x plus 5 times x plus 3, and that's x plus 3. Well, notice that is what your least common denominator is. That's what's missing from all of them. X plus 5, x plus 3. And now I'm going to go through each of these rational expressions here, and I'm going to figure out what's missing here. Okay, this has an x plus 5. That means I need to multiply this by x plus 3. Because my x plus 5s there are going to cancel out completely. We can just write it like this for now. Sorry, I didn't mean to put 2 parentheses. Here, this 18. Oh, well, when I go to multiply this x plus 3, x plus 5, that's exactly what that denominator is equal to. That's how we got this whole thing. So that's really just going to leave me with a plus 18 equals. And then I have that 9 divided by x plus 3. Well, what's missing from here is your x plus 5, because those are going to cancel out. So you're going to be left with 9 times x plus 5. Now your next step here is going to be to FOIL out this parenthesis. Let's get an x squared. Let's see what this is really equal to. I'm trying to solve for x. So starting with my x, I'm distributing that into my second parenthesis. I will have x squared plus 1x. Then I'm going to have a plus 3x plus 3. Then I'm going to carry down this plus 18 equals, and sure, we can distribute this over here. I'm going to have a 9x plus 45. Now this looks extremely long and intense. So let's start by making our life easier. Let's combine those like terms. Okay, this has an x and this has an x, so I should absolutely bring them together. X squared plus 4x. Oh, these are two numbers. I have a positive 3, I have a positive 18. Only makes sense to rewrite that as a 21 equals 9x plus 45. All right, my next step here is, let's bring my like terms together. The only way you can bring those like terms together is by performing that inverse operation. So I absolutely need to subtract this 9x and this 45 from both sides in order to isolate that variable. So I'm going to have x squared minus 5x And then you are going to do negative 45 plus 21, which is going to give you a negative 24 equals 0. And now you're up to, okay, I want to solve for x. I know since this is a quadratic function here, I must be factoring that. Yes, you must absolutely use ABC method. So my factors of negative 24 will be negative 12 and 2. It will also be negative 6 and 4. It will also be negative 8 and 3. And we found our pair there. So I have x minus 8, x plus 3 equals 0. And your last step here should be splitting those and setting them equal to 0. X minus 8 equals 0, x plus 3 equals 0. And x will be equal to negative 3. X will be equal to 8. Now your directions specifically said to solve, which we just did, and reject any extraneous solutions. So if I was to plug in 8 into any of my x values there, is it going to give me 0 in my denominator? You can test it yourself. If you were going to plug in negative 3 into any of those values in your denominator, is it going to give you 0? Yes, absolutely, because when I have 9 divided by negative 3 plus 3, that's going to give me a 0. And that's not possible. So that is going to be an extraneous solution. That is an extra solution. So your only solution here is x equals 8. Extremely hard concept, guys. Take the time to rewind, watch the video. I'm going to give you 2 days to get this assignment in. If you need to schedule office hours with me, send me an email. We can do one-on-one tutoring. Good luck, have fun, try your best.